topics, but 3 very confusing and easy. Very easy, but it confuses to some extent. The first thing we will learn today is called minor of a determinant. Minor of a matrix or minors. After minors, we will be reading something called cofactors. Then we will read something called adjoint of a matrix. Okay. Now minor. Suppose you have, let us say we have a matrix. Since we will be dealing with determinants, everything will be square. Suppose you have a matrix whose order is equal to 2. All right? And you take your matrix as A and you have to make it as order 2. So let's make it A11, A12, then B, or say not B, let's keep it all in A's, it becomes easy. A21, A22. Okay. Children, when we talk about minor, minors are evaluated for every element of a matrix. So you will have a minor for every element of the matrix, and the matrix will be what? Square matrix. Okay. So let's say we want to evaluate the minor for A11. क्या हो गया? We want to evaluate the minor for A11. Job is very simple. This is a 2 by 2 matrix. 2 by 2 matrix means your God is with you. Close the column with A11. Close the row with A11. What do you see? A22. So it is A22. Understood? Similarly, if you want to find out the minor for A12, close the row with A12 and close this. I see A21. Minor of A21. This. I see A12. Minor of A22. I see A11. Some new bata shoe type smell is coming. That shoe adhesive smell is there, right? Something new. Is this understood? Minor becomes very easy. So we say if you have a matrix of order 2, then your minor is a single element. Clear, bacha? But the world is not so kind to you. They will always try to make your life miserable. And your life can be made miserable by considering a matrix of order 3. Very good. See, I really like, Neha, the way you are accepting that life will be miserable. Okay, order 3. So let's make a 3 order matrix. A11, A21, A31, A12, A22, A32, A13, A23, A33. Right? And now we are going to find out, all these you have done actually in the previous, but you didn't know the names. Minor of A11. Now, if you do the minor of A11 and you close the row and the column containing A11, you will land up with a determinant. You will land up with a determinant which is A22, A23, A32, A33. Do you agree or not? See, if I close this and I close this, I land up with this. This determinant value will be its minor. Do you understand? The determinant value. And similarly, I'm just taking a random one, minor of say A22. I want to find out the minor of A22. Can you tell me what is minor of A22? The minor of A22 would be A11, A13, and A31, A33. You have to solve this determinant. Means, how much will I get here? A22, A33 minus A23, A32. And here I would get A11, A33 minus A31, A13. Children, you have done this already. Well, doing the evaluating the determinant of a matrix. You just didn't know the name called minor. Zoe madam, is this clear? If it is a square matrix of order 2, life becomes easy. If it is a square matrix of order 3, all you need to do is that you have to calculate the determinant value. Did you get it? Based on this, we will have another one thing called cofactor. Okay. You find minor to an element, a cofactor is always found for a minor. Cofactor means cofactor of a minor. You know what is the cofactor? The cofactor is the -1 to the power I plus j, which you had used in determinant. So what was the value of determinant that you calculated? Determinant was cofactor minor plus cofactor minor plus cofactor minor, or it was cofactor minor plus cofactor minor plus cofactor minor. So cofactor of is I. So let us say cofactor of A11 for this particular matrix. It will be what? Cofactor of A11 is the minor A22 multiplied by -1 to the power 1 plus 1, which is nothing but A22. Cofactor means just assigning the -1. So in crude language, what we can write, cofactor means assigning the -1 part, -1 to the power I plus j. Have you understood this? Okay. So before we proceed further, what we will do is that we will take up one example where we will be checking out what is the cofactor. We will check out what is the minor, and then we will construct it. Are we fine? Okay. So don't look into the books, be honest, which you are. And I give you a determinant. There is a determinant which is 2 minus 3, 5, 604, 1, 5, minus 7. Your job is to list out all the minors and all the cofactors. Now, how will you do it? It's like this. See, I've asked you to list out the minors and the cofactors. You will do it in this way. You will do it in this way. Minor M11, cofactor A11. Do you understand what is M11 means this? What is the value? So minor M11, you will get a value, cofactor. Finally, you make this matrix. Minors and cofactors. Just practice this once. Okay. Shall we do it together? Okay. So the first one, the element is 2 and the minor of M11. M11 would be 0, 4, 5, minus 7, which is equal to 0 minus 20, which is minus 20. A11 would be 20. A11 minus 20. A11 is -1 to the power 1 plus 1 multiplied by minus 20. So the next one, M12. M12 would be 6, 4, 1, minus 7, minus 42, minus 4, minus 46. Cofactor would be 46. M13. Cofactor will be 30.
So that would be 21 minus 25.
21 minus 25, sorry. 4. Negative 4.
Negative 4.
21 minus 25 is negative 4. 1 minute. And it will become plus 4. This will be minus, this will be minus 4. And A21 will become 4. M22. $18. All okay? At this stage, once you have done, let me know once you have done. All of you have done by now? Can you write the cofactor matrix? Let's write the cofactor matrix now. Huh? Which one?
Minus 251 minus 10.
Which is it? M22. M22. M22 is 2, 7, 1 and 5. Yeah. Sorry. So this is, sorry, this is 2, 2, right? So it's 2, 5, 2, 5, 1 and negative 7, right? So which is equal to negative 14 minus 5, which is equal to negative 19. And since this is on this, so this one will retain as minus 19. This will remain as minus 19. Fine. So let's complete this. This is done. Then we get 4, 19th, 4 minus 19, 13. Then we have 12, 22, 18. Check this. This is the cofactor matrix.
Minus 30.
Which one?
After minus 20.
Minus 19, minus 13. Yeah, this is minus 13. All fine. This is called cofactor matrix. Right? Now what you do, try to find the transpose of cofactor matrix. So it will become, my transpose is swap the rows and columns. 46 minus 19, 22, 30 minus 13, 18. This is transpose. Minus 24, 12. Which one? Which one? It's you can't say the number. 12. Where is 12? Yeah, 12 is minus. Yeah, it's minus 12. Then it's 46 minus 19, 22. This is the transpose of the cofactor matrix. This is called adjoint. Adjoint of the original matrix A. We denote it by ADJA. So three things you learned. What is minor? Minor is to an element. Cofactor is changing the minor itself with the minus one part. And then how to find out the cofactor matrix, and then finding the transpose of the cofactor. The transpose of the cofactor will be known as the adjoint. Can I change the screen? Okay. And check whether your understanding is clear on this or not. Given a square matrix, all you are trying to do, you were exempted from finding inverse in matrix chapter, but the inverse will come here. Given a square matrix, the first thing you should know is how to evaluate minors. Then if you know the minors, you should know how to evaluate the cofactors. If you know the cofactors, you should know how to find out cofactor matrix. If you know how to find out the cofactor matrix, you should know how to find out the adjoint matrix. Right? Minors will be like a determinant. Cofactors will be negative 1 to the power I plus j multiplied by the determinant. Cofactor matrix, you know. Adjoint is transpose of the cofactor matrix. Adjoint is cofactor. Adjoint is transpose of cofactor matrix. Okay. So far, you know. 5, we will find out what is the inverse of A. Given a square matrix A, how to get the inverse of A? A inverse is equal to A cofactor. Sorry. Instead, you can write adjoint A, which is basically a matrix, divided by the determinant of A. Now, determinant, you need not do the hard work. Listen, you have done the hard work here itself. How do you calculate the determinant? You calculate the determinant can be calculated very easily. A determinant is nothing but you took A11, the cofactor of A11, into the minor of A11. Just see, you had the minus 1 with which you had multiplied. So you have these values already. So you just need to solve that. Okay. So this is already solved for you. Just write these steps, because this is what we will be needing now. You need to know the cofactor matrix. Once cofactor, you transpose it, you get the adjoint. Adjoint divided by the determinant value will be known as the cofactor matrix. Sorry, inverse of the matrix. So let's take one problem on this type. Ready? Let's take a problem on this type. Don't worry, it's very easy. So the problem is in this manner. It says if A is equal to 1, 3, 3, 1, 4, 3, and 1, 3, 4. This is A. And A is a matrix. A is a matrix. Verify A into adjoint of A. A into adjoint of A is equal to determinant of A into inverse, and then find A inverse. A into adjoint of A is same as determinant of A into identity matrix, and find A inverse. A inverse, we know A inverse formula can be found straight away by multiplying, dividing the adjoint by the determinant value. So shall we? Our first job would be what? To find the adjoint of A. In order to find the adjoint of A, we have to start from the minor of A. And we have to find the cofactor matrix. So let's write. Let's straight away go for cofactor matrix of A. Chalo, can we do it verbally? Cofactor matrix of A. 4 4s are 16. 16 minus 9 is 7. 7 retains its value. Then 3 cancel. 1 into 4 is 4. 4 minus 3, which is 1. But 1 becomes negative 1.
No.
This element. 1 into 4 minus 1 into 3. Then this element 3. It will be 3 ones are 3 minus 4. 3 minus 4 is minus 1. Minus 1 will be retained. We'll do it together, it will be faster. Now, let's do for 1. Close this, close this. 3 4s are 12 minus 9. 12 minus 9 is 3, but it will take negative 3 because this position is negative. Then let's do for 4. Once I write this, you can copy. Help me out. Let's do for 4. You cross this and cross this. So you have 1, 3, 1, 4. 1 4s are 4 minus 3, which is 1. This. 1 into 4 is 4, minus 1 into 3 is 3. 4 minus 3 is 1. And this is a positive position, so number remains unchanged. Let's do for this one. This closes, this closes. 1, 3, 1, 3. 1 into 3 is 3. 3 minus 3 is 0. Now we do for this one. 3 3s are 9. 9 minus 12. 9 minus 12 is how much? Minus 3. Retains minus 3 because this is a positive position. Then we do for this. If you do for this, this close, this close. 1 3s are 3. 3 1s are 3. So this will give me a 0. Then we do for this. If you do for this, 1 4s are 4. 4 minus 3 is 1. And 1 retains the value 1. Right? Then I'm writing adjoint also. Adjoint A will be do this much and come again, we'll do together again. A into adjoint of A. Fine? Till adjoint of A, are we fine? Okay. Now help me with A into adjoint of A. How will you multiply? This is A. This, remember, this one doesn't come in picture. This and this. So you will be multiplying with rows into columns. So let's try rows into columns. 1 into 7 plus 3 into minus 1 plus 3 into minus 1. Check this. 1 into 7 plus 3 into minus 1 is 3. And then x is 0. Then 1 4 3. 1 into minus 3 plus 0, 3 into 1. The last one. Minus 3, minus 3, minus 6 plus 7, 1. Minus 3 and plus 3, 0. Minus 3 and plus 3, minus 3 and plus 3, 0. 1 into 7 is 7. So 4 into minus 1 is minus 4 minus 7. So here we are getting a 0. What are we getting here? 1 into minus 3 minus 4. So here we'll get a 1 and here we'll get a 0. And similarly we'll get a 0 here. 3, 4, 7, 0. And 1 into minus 3 is 3. This is 4. This is a right. Now you have to do determinant of A into I. Let's calculate what is determinant of A. Shall we? So if we take 1, 4 4s are 16. 16 minus 9, 7. Then minus 3. Minus 3. This is minus 3. And then we will do for this. 1 4s are 4. 4 minus 3 is 1. Right? And then we get a positive 3 and calculate 3 and this gone. 1 into 3 is 3. 3 minus 4 is minus 1. So determinant of A will come as 7. Right? So your RHS is determinant, your RHS is determinant A multiplied by identity matrix. So obviously it will become a 7. Which one? No, determinant of A cannot be 1. No, determinant of A has to be 1. Yeah. Minus 3 is 6. Determinant of A has to be 1. Correct. Because it has to be identity on this side, right? Yeah, you're correct. 1. I'm sorry. So this is 1, which is being multiplied by the identity matrix 1 0 0 0 1 0 0 0 1. So you are left with 1 0 0 0 1 0 0 0 1. And here you see your LHS. This was your LHS. Is exactly tallying with RHS. Only you need to have some precision and care. That's all. Now we'll calculate what? We'll calculate A inverse. So A inverse is given by adjoint matrix A divided by determinant value of A. So what is the adjoint value? A. So A inverse will be the identity matrix itself. Don't you agree? Determinant is 1. Understood? One more knowledge part and then we can go straight away to exercises. I mean, these are all have been moved up. Theorems and all are not there. But yeah, this is taken off. So taken off. So you now know that if you have a square matrix, your exercises are all based on this. If you have a square matrix, you should know how to calculate minors. You should calculate how to calculate cofactors, Once you have calculated cofactors, you should know how to calculate adjoint. If you know adjoint, you also know how to calculate inverse. Now we will use the inverse thing for solving simultaneous equations. Simultaneous linear equations. 2 variables or 3 variables, it does not matter. If it is 2 variable, it will be a square matrix. If it is 3 variable, it will be a matrix of order 3. Okay. So in this, what you need to remember, children, the order in which you write the equation, the equations are a1x plus b1y plus c1z is equal to d1. Do not write it as equal to 0 by bringing d on this side. Keep the constant term on the right hand side. My next equation is, this is the maximum that you can get, a2x plus b2y plus c2z is equal to d2. Third equation is a3x b3y plus c3z is equal to d3. Is this understood? Now, how do you set up your matrix for this? Your matrix setup is very easy. You will take all the coefficients a1, b1, c1, a2, b2, c2, a3, b3, c3, right? With this, we will have another matrix called x, y, z. Understood? And then on this side, you will get d1, d2, d3. Okay. This is the setup. The setup is represented like this in matrix order. This is a matrix A. A multiplied by X gives you a matrix which is, say, B. This is the matrix B. A multiplied by X gives you the matrix B. All you are interested is to find out X. So X will be equal to A inverse multiplied by B. X will be equal to A inverse multiplied by B. Did you understand? And then this matrix will also be a 3-row, 1-column matrix. Then X for its corresponding part. Now try to put the idea in your head. How will you get the A inverse? Once you get the A inverse, multiply it with B. And then you automatically get XYZ. Shall we do it for a simple problem? So our job is to write the equation with the constant term on the right hand side. Okay, let's take one small simple equation and see whether we can do it or not. Let's start with a simple equation. Okay, let's say like grade 9 we have got linear equation in 2 variable, 2x plus 5y equal to 1, 2x plus 5y is equal to 1, right? And we have 3x plus 2y equal to 7. They should have given us to solve this by elimination method. What is the necessity to go this way? So you formulate your A matrix. Your A matrix is what, children? All the coefficients 2, 5, 3, 2. Agreed? Your X matrix is the variables. Your B matrix is the constant taken on the right hand side. Agreed? The setup would be A into X is equal to B. So X is equal to A inverse B. Now your job will be to compute A inverse. Very good. So how to compute A inverse? Let's find out A cofactor matrix. A cofactor. Come. Here the cofactor matrix will be very easy. Because cross 2, you have 2. Cross 2. Oh, 4. 2. Cross 5, you have got 3. Cross 3, you have got 5. Cross 2. This is the cofactor matrix. It's very easy. Then we need to find Adjoint A. Adjoint A would be 2, 5, 3, 2. Same.
Yeah. Similar.
But one thing you did not take care. What's that? How can the adjoint and the matrix be the same? The signs you did not take care. So it is 2. For 5, it will become a negative 3. Here it will become a negative 5 and 2 retains 2. So it would be 2, negative 5 and negative 3, 2. Can we calculate what is the value of determinant of A? The determinant of A would be 2 to the 4 minus 15. Children, what is 4 minus 15? Negative of 11. Can you calculate what is A inverse now? Adjoint of A over determinant of A. So that will become minus 2 by 11, right? Then 3 by 11, then 5 by 11, and minus 2 by 11.
Yeah.
2 to the 4, adjoint by determinant, minus 11, na?
But five will be on top. 5 and 3 will interchange.
Adjoint is, oh, I took it on this one. Sorry. This is inverse. Now we have to do A inverse into B. Achha, what is A inverse? A 2 cross 2 matrix. What is B? B is a 2 row 1, right? Look at B. B is 2 rows 1 column. So these are same. Ultimately A cross B will be what? A 2 cross 1. That is what exactly you are looking for. So let's multiply. Okay. So you're multiplying this with B. So minus 2 by 11 into 1 is minus 2 by 11 plus 5 by 11 into 7, which is 35 by 11. Very good. Then 3 by 11 into 1 is 3 by 11 plus, so it will be minus 14 by 11. ठीक है बच्चा? Which becomes 33 by 11, which is 3, and which becomes minus 11 by 11, which is equal to 1. Therefore, x is equal to minus 1. So, x by y is equal to 3 minus 1. So, x is equal to 3, y is equal to minus 1. You can check. If you put 3 and minus 1, 2 3s are 6, minus 5 is equal to 1, which is correct. 2 3s are 6, and oh, sorry, this is 3. 3 3s are 9, 9 and 2, 7, correct. But your bad luck will be very bad. So let's make your bad luck bad. The last one example, and then this chapter ends. Then you can also go home, and from next class we can start our continuity and differentiation. Okay, so let's do one small problem. Easy data. Easy data. Solve it. X plus y plus z is equal to 6. Y plus 3z is equal to 11. See, you've got a 0. It's good for you. And the question they have given is x plus z is equal to 2y. So please transpose this. X plus z plus 2y is equal to 0. So this, and this. Oh, x plus z minus 2y. Sorry. Mistake hota hai na. x plus z minus 2y is equal to 0. Chaliye, let's do this one. So your A matrix would be 1, 1, 1, 0, 1, 3, and then 1, minus 2, 1.
No. 1 minus 2.
That is Z.
Oh, yeah.
हाँ, हर टाइम मैं गलत नहीं होता हूँ. X is equal to, and B matrix is equal to, what is your B matrix? 6, 11, 0. So more are the zeros, more your life is easy. You can do it. A cofactor in one shot. Are you ready to take A cofactor in one shot? 1 ones are 1, 1 plus 6, 7. -3 नहीं, 3 हो जाएगा वो. 1, 0. Actually, you can use this value itself. 7 plus 3 plus minus 1. Check up to determinant value. You know how to find the determinant value? Add these 3 terms. You did not cross check again. 9 by 3 is 3. Here LCM will be 9. 42 minus 33. 42 minus 33. 43 minus 9. So this will be equal to minus 1. So finally your check. They have got the answer as 1, 2, 3. I got minus 1, 2, 3. Oh, 42 minus 33 is bang my head with a club. This is plus. Answer is correct. All you need is experience. Experience. Experience.